In this video, we are going to learn how to make our drawings precise. We can make our drawings precise by using constraints and setting dimensions. Constraint means to limit. We can use constraints to give our drawings rules. These rules are essential to controlling the size and shape of our 3D printed parts. When designing for the real world, this is the difference between a 3D print being 1 or 100 inches tall. It is the difference between a parallelogram and a square. We are familiar with constraints, even if we are unused to referring to them by that name. Shapes and geometry are defined by their constraints. Let's look at a rectangle. A rectangle has 4 sides. The sides that are opposite to each other are both parallel and equal. The sides meet at a 90-degree angle. Let's see what happened when we draw a rectangle in Inventor. After drawing the rectangle, if I drag and select the rectangle, we can see a bunch of symbols appear. These are automatically generated constraints. These symbols represent the rules for a rectangle. Each symbol is near one of the lines it is constraining. When I hover over the constraints, they highlight the parts they are attached to. Let's learn what these symbols mean and how to use them. The first constraint is the coincident constraint. It is used to attach the center point of a circle onto a line, or make two endpoints join together. Here, I have a circle and I want it to be on that line. I click the coincident constraint, the circle, and then the line. If I have two lines that I want to join end to end, I can click the coincident constraint, then one vertice, and finally the second vertice. This constraint does not leave a symbol on our drawing. The next constraint is the parallel constraint. The parallel constraint makes two lines parallel to each other. If we look back at our rectangle example, we can see the parallel constraint symbol, and when I hover over it, it will highlight opposite parallel sides. I can apply this constraint to an additional line by clicking the parallel constraint and then the lines I wish to make parallel. In contrast to the parallel constraint, we have the perpendicular constraint. The perpendicular constraint makes two lines meet at a 90-degree angle. Looking again at our rectangle example, we can see that one corner has the perpendicular constraint applied to it. This constraint is only applied to one corner because the two parallel constraints also applied to this shape mean that every corner will meet at a 90-degree angle. If I want to add an additional perpendicular line off the rectangle, I can do so by clicking the perpendicular constraint and then the two lines I want to be perpendicular. Moving right along, we have the collinear constraint. Collinear constraint makes two line segments share the same direction as if they were the same line. This is useful to making different parts of the drawing line up. In my example, if I want to make the line segment A and B the same distance from the bottom, I can use the collinear constraint and then click the two lines. The concentric constraint makes two circles, ellipses, or arcs share the same center point. In my example, I have an arc, an ellipse, and a circle that I want to align together. I click the concentric constraint and then two of the shapes. As I have three shapes, I need to repeat this step one more time. First, making sure I have the constraint active, and then selecting two more shapes. The vertical constraint is useful for making a line to be parallel to the vertical axis of your drawing. When using this constraint, you click the constraint and then the line you want to be vertical. Your drawing might not have a vertical axis, so this won't always work. The horizontal constraint works exactly like the vertical constraint, except it forces a line segment to be horizontal. Just like the last constraint, you only need to select the constraint, then apply it to the line segment. If your drawing does not have a horizontal axis, then this constraint will do nothing. With the previous constraints, we can set relationships between shapes. However, when we specify whether a line is parallel, perpendicular, or collinear, we don't define its length. What if we want two lines to meet at a specific angle other than 90 degrees? For that, we use the dimension tool. The dimension tool can be used to specify the length of line or the radius of a circle, ellipse, or arc. It can also be used to set the angle between two line segments. The dimension tool can be used to specify the distance between two objects. I'm going to use the dimension tool to constrain this triangle. I want this side to be 20 millimeters long. I click the dimension tool, then the line. That will make a label appear. I can place this label anywhere and it will have no negative effect on the drawing, but a carelessly placed label can make a drawing appear messy and hard to understand. I'm going to put my label on the outside of the shape with a bit of room between it and the shape. When I click, I place the label and then I can type in my length of 20. Because I set the default units to millimeters, it will fill in mm's. I can overwrite the millimeters by typing in a different unit such as centimeters or inches. Click the checkbox or hit enter to save the dimension. We can use the dimension tool to set an angle. I want this triangle to be a 30, 60, 90 degree triangle. To set an angle, I click the dimension tool, then one side of the triangle, and then the second. This will bring up a label. With the third click, I will place the label. This time the placement of the label matters because if I place a label on the inside of the triangle, I'm specifying the inside angle. Whereas, if I put the label on the outside, I'm specifying the outside angle. I'm going to place it on the inside. The box will appear for me to type in my dimension. For this angle, I will choose 30. I can set another angle using either the perpendicular constraint or the dimension tool and typing 90. The last use of the dimension tool is to specify how far apart shapes are. If I want to make my square be 10 millimeters apart from the triangle, I can do that by selecting the dimension tool. Clicking one side or vertice of the rectangle and one side or vertice of the triangle. The third click places the label and I can type in my distance. Hitting enter or clicking the green checkbox will save the dimension. Sometimes, when working on a design, a dimension or constraint may need to be changed. You can change a dimension by double-clicking on the label. When I change the side length of the triangle, it will continue to follow the other applied constraints. See how after I change the side length, the entire triangle has become bigger? If you want to delete a dimension, make sure you are not in a tool by first hitting the escape key. Then click the dimension you want to remove. It should turn blue, indicating it was selected. Hit the delete key to remove that dimension. If you want to delete a constraint, you first need to see it. Let's turn this rectangle into a parallelogram to demonstrate this. The difference between a rectangle and a parallelogram is that a parallelogram has two sets of parallel sides that do not meet at 90 degrees. I need to get rid of the perpendicular constraint. To delete the constraint, I first need to be able to see the constraint. I can do this by clicking one of the lines that is affected by the constraint, or drag select the entire shape. This should cause the constraints to appear. I can select the constraint by clicking on it, and it should gain a red outline, which means I have it selected. Hitting the delete key will remove the perpendicular constraint. The rectangle won't change its shape until I give it a different constraint, which will force it to adjust. I can supply that different angle by using the dimension tool. I select two lines that meet and place my label. When I input 45 degrees and hit enter or click the green checkbox, we can see that change take effect. The parallelogram moved to accommodate the new dimension. It may have moved in a way that you are not expecting. That is because there is a vertical constraint applied to one of the sides. If I want this parallelogram to have a different orientation, then I need to remove the vertical constraint by clicking on it and hitting the delete key. I can now put a horizontal constraint on the side and it will change its orientation. Working with constraints can seem weird. Inventor will try to follow the instructions you've given it. Sometimes it may seem like it has a mind of its own. When this happens, it's usually because it has an automatically generated constraint that you didn't notice. Let's make a new shape and see if we can spot those constraints being added. See the dotted lines? Those are indicating the constraints that we will add if we click. When we are working with constraints and dimensions, you may occasionally get a warning that your drawing is over-constrained. An over-constrained drawing means that there is already a rule in place that is conflicting with what you want to do. Try clicking parts of the shape that you are trying to constrain and look for other parts to highlight and the constraint symbols to appear. You can use the delete key to try removing some of those constraints, and perhaps your drawing will no longer be over-constrained. I have a last few tips to help you out when using sketch constraints and dimensions. Set the shape's constraints such as parallel or perpendicular first, then specify using the dimension for how big it is. Putting a dimension in too early can cause your design to distort. If you are applying a constraint or dimension and it distorts your image, undo the last constraint or dimension and then try putting a constraint in a different spot to lock down the shape into what you want. Dimension larger objects before smaller objects. It's easier to set the overall size and shape of your design with its biggest features and then fit the smaller ones in. In conclusion, we can make our drawings more accurate and precise by using the dimension tool and various constraints.